Okay, it's running on 80 milliamps now. It used to be 140. I ran the 4 motor coils in series. So I raised the impedance of the motor coils. It's going about 500 RPM, 15 volts. So it's a little bit less than 1 watt it's running on now. I want to show you the pickup winds. What the pickup winds are is, here's a motor coil. It's wound on a sewing machine bobbin with some Litz wire. It's about 16 strands of very thin wire, all insulated. It's for high frequency Litz wire. It's old Soviet stuff. So here's the motor coil. This receives pulsing power. The magnets go in front of it, makes it go. So there's nothing happening behind here. So I put some more coils sharing the core. So now every time you pulse this front motor coil, it makes power in these two, both from being close to it and also mostly from the core that stretches all the way back. And I could have done more. I could have put even another one back here, maybe I should have, because there's still pretty good magnetic power on the very back end of these cores. The cores I made out of toothpicks, 3 toothpicks put together. Then I put Litz wire, 22 gauge Litz wire, soft steel. Florist wire, soft steel florist wire. It's green enamel coated. They use it for doing flowers and stuff. And so this is kind of like a laminate steel core, really. So anyways, so that's the cores in there. And you see what the pickup lines are, those 2 coils behind the motor coils, you know. So the power from the pickup coils I'm getting is non-reflective, more or less, because if you take the pickup, I soldered them all together. I have all the pickup lines in series. There's 2 coils for each motor coil, so there's like 8 coils and they're all in series. And this is it coming out. Each pair of pickup lines is about 37 ohms. So it's about, I don't know, 120, 150 ohms worth of pickup lines behind the motor coils, the 4 motor coils. So here's the output of the pickup lines. I rectified it with a single diode here, same diode I used for the backemf recoil flyback stuff. Touch them together and it goes the same speed. And what else? Hold on a sec. Okay, so I rectified the pickup lines with a single diode, not a full weight bridge, a single diode. And now I'm going to run it into this cap bank down here, which is 14 in parallel, 100 UF cap, 63 volts. So it's like 1400 UF cap. It's pretty big for this stuff. So I'm going to hook up the pickup lines. Can you see the voltage over here? It's right 1.9 now. Pickup lines are on. This is the pickup lines. Notice how it goes up, keeps going up. It's like it's catching the back EMF spikes as well as just the transformer effect and the induction effect. Now I'm going to do a little experiment here. This wire right here goes to the, coming off of this steering diode, the very fast steering diode that catches the back EMF recoil. So I have like 21 volts in the capacitor bank now, and I am going to, let me move this a little bit Glare. So I'm going to run the 26 volts. Okay, now I'm going to run the let's call it back EMF recoil into that bank 2. Now what are we up to? 34 volts. Now I'm going to short it out. You'll hear the pop. Okay, now it's down to 7-8 volts. Now I'm going to hit it again, just touch it with the back EMF recoil from the MOSFET, you know, the flyback. Oops, I hit the ground there accidentally a little. Okay, I'm going to do it again. It's down at 24 volts. Get it down there. 7 volts. So that's just the pickup lines filling. Now the direct diode from the MOSFET, the steering diode, goes up like that, very quick. You hear the motor lug a little bit when you do it. Here, do it again. Listen to the motor. Goes down a little bit, but it's up to 28, which is pretty good. Now I'm going to do it kind of pretending like I'm pulsing it in, just tapping it. Now it doesn't lug at all, and it's up to 28. So this is the pickup lines behind the motor coil, rectified with a single diode into this cap bank down here, and it's also as well the back EMF recoil flyback from a steering diode going in. If I did it again, look how much juice is in there. See, now there's a little bit of lug because I left it on, but look, if I pulse it, it goes to the same amount. So this is should have a timing where this back EMF recoil is pulsed out, not just left there, but it might work okay just leaving it there too. Okay, so there's that. Now I want to show real quick what happens with a regular generator coil. Just one coil of the 12 I have. Watch what happens when I short it out. It breaks the motor. It breaks Lenz's law. So something needs to be done with that. Either put magnets behind each of these, like Romero UK did. I have a video where I do it pretty successfully with something just like this back in the United States. And also you can get the RPMs to be just right so that the delayed lens effect takes effect. The thing, Karl Heinz thing, there's a lot of videos on that where you get kind of an RPM window and it speeds up when you short the coils or you add load. Another way is to short the coils out at the sine wave peaks with a switch, and put it into capacitors, then unload the capacitors in a second stage, like I did with the back EMF recoil flyback in the video before this. Another way would be to chop the generator coils. Don't just like take them out like this. Like bring the generator coils out at a certain part of the sine wave. And you can do all this stuff I just said in conjunction with each other. And also I'm working on putting a kind of a buffer capacitor in series, and it was kind of successful. I worked on that a little while ago. I'm going to show it later. Also, you can take that back EMF that I just shot through the pickup coils, the pickup, the power coming out of the pickup coils into the capacitors. What I just did there, you could do that with the generator coils too. So, and you can combine the pickup coils with the generator coils. Lots of things to do. So, I just wanted to show you the pickup lines and how the motor coils are made. Show you a little bit of Lenz's law. And so, okay, thanks a lot. Okay, bye.